Hello, welcome to the ninth and final lesson in Spiral 4. So we're revisiting partial and direct variation, okay? And all I want you to be able to do is differentiate, be able to tell the difference between them and explain your reasoning. All right, so if you're given a situation, how do you know whether it's direct or partial? So we're going to go through the following three examples and figure out which is which. This is the strategy I would use. A plumber charges $60 for a consultation fee. That means they come out and tell you what's wrong, and then $30 an hour to do the work at your house. So what I'm going to do is I'm going to do a quick little T-chart here. So I got hours and I got money. So plumber comes out. He doesn't work at all. Okay, no hours worked. How much is it going to cost me? Well, I have to pay $60 for him to take a look at the problem. And then if he works 1 hour, it costs me an extra $30, so then it becomes 90, so plus 30. Is this a direct or partial variation? The key for a variation is that when x is 0, because the plumber charged us an initial value or an initial fee, a down payment, 0 hours cost me $60. That means this is a partial variation, all right, because of the initial cost of $60. All right, I had to pay money before anything got done. Okay, so that's your initial cost. The next situation, if I approach it the same way, it costs $15 every time you take your dog in for a flea treatment at the vets. All right, so if I put visits here and cost here, if I don't take my dog to the vet, I don't get charged anything because they can't give me a flea collar if I don't take them to get the flea collar. So no visits means no money, but if I show up, it's going to cost me $15. The key again is that 0, 0. Because it is 0, 0, this is what you call a direct variation. All right, and it's because of the 0, 0. The third example, a salesperson at the Gap, okay, should be capitalized, it's the store, is paid $60 per shift plus 20% of every dollar she sells. So this is an example of, and we talked about this in Spiral 3, this is commission. All right, this is commission. So when we figure this particular chart out, so this would be sales and how much money you make. So if you come into work on a shift and you sell nothing, absolutely nothing, you don't even leave the back room, you stay in the lunchroom the whole time, how much money are you going to get paid? The answer is $60. You get $60 no matter what you do on your shift. If you were to get, say, $100 of sales, well, then you'd get 20% of that, which is $20. So you'd make $80. But the key here is that initial step. All right, this is a partial variation because it's not 0, 0, it doesn't go through the origin. All right, so just a quick little trick using a T-chart to figure out whether you got a direct or a partial variation. Part 2, write an equation for each of the following situations above. How does the equations for partial variation differ from direct? Okay, so we already know this from previous lessons. So down below, so for number 1, the plumber, what is the equation? Well, the cost is going to equal, I have to pay $60 to get the plumber to show up, and then every hour he works is going to cost me $30. All right, so here is your initial value. Here is your unit rate or first differences. Okay, so there's number 1. What about number 2? It costs $15 every time you take your dog to the flea treatment. So cost equals your first difference. So that's $15 per visit. So let's call that X. and it doesn't cost you, there's no initial value. All right, so initial value is 0, because if you don't go, you don't have to pay anything. All right, so the difference is these partial variations have an initial value, whereas direct variations have no initial value. Now this last one, this is not one that you would see at the grade 9. It won't be on EQAO, just because the equation's a little trickier, but we'll do it anyway. So your salary, so let's call it S for salary, or how much money you're going to make. You get $60 per shift. So I guess I'll use, I'm just going to write it in here. All right, so $60 per shift. So you get 60 times each shift, plus you're going to get 20%, so as a decimal, 0.2 times your sales. So this is a really this is why we don't have this one in the grade 9 course. It's complicated because you have extra variables. You have a shift variable and the number of sales variables. So you won't see that on EQAO. Okay. All right. So there you go. That is the equations for those 3 examples. 1 and 2 you would expect on an EQAO or on a test. All right. So the next example goes back to the plumber question again. $60 for a consultation, $30 to do the work at your house per hour. So here we got hours again. Hours, this is the cost. So we already set this up on the other page. 0, 60, 190, 2, 120, 3, 150. Okay, make an equation, and we can graph this. So on the bottom here, we'll go hours, and on the y-axis, we'll go cost. So let's go every 5 squares is 1. I just want to show this. 1, 2. So there's 2, 1, 2, 3, 4, 5. 3, 1, 2, 3, 4, 5. So we're just going to look at the first 4 hours. 1, 2, 3, 4, 5. Let's go up by 50s. 5. So every square, I guess, is $10. Make sense? All right. So at 0, I have to pay $60. 1, I have to pay 90. 2, I have to pay 120. 3 is 150. Right there. Okay? Quick and easy. There's our graph for situation 1. Okay? So we plot it in your table, no problem. The plumber adjusts his fee. All right, so situation's changed his prices. He increases the consultation fee to $80. So he says, you know what, how about I pay you $80, or just charge you $80 up front and leave it at $30 an hour. So this is no savings for me. B part, he puts his consultation fee up to $80 and increases his hourly fee. So I don't like either of these situations. Make new tables and equations and graph them on the same axis. So we still have hours and we still have money for both of these. So this is going to be situation A, situation B. All right. First one. At 0, it's going to cost me $80. At 1 hour, still $30 a visit, so that's, or an hour, that's $110. Adding 30, it's $140 and $170. The other one, he increases both. So 0, 80, and now instead of going up by 30s, we're going to go up by 40s. 120, 160, 200. So they want us to plot both of those on the graph above, which is not a big deal. I'm just going to change colors here. So I'll use red for that one. So I'm going to make A will be in green. So 0, 80. So 60, 70, 80. 1 and 110. 2 and 140. 3 and 170. So scroll up a little bit here. Draw the green one. It's best I can draw freehand without a ruler. Okay. So there we go. What happened there? If we take a look and see what happens here, we see that the two lines are still parallel. They're just higher. So the higher initial value moves the original line up. Original line up. So it stays parallel. These two lines still are parallel to each other. The only difference is that the green one is now $20 higher every time. What happens if in B, so I'll do B in black, we go with this system. So we've got 0, 80. So it's going to start at the same as the green one. 1 and 120. 2 and 160. So boom, boom. And 2 and 200. Oh, it's going to be up here. So what happens in situation 3? What happens if we increase the first differences? So a higher first difference will make the line, how would you describe it? It is steeper. All right, it's steeper. It's going up faster than both the red and the green. All right. On to the last part then, just to summarize. Increasing the unit rate will make the following changes too. So to the table, to the graph, and to the equation, what happens to the table? Y values go up faster. All right, because you're adding more each time. To the graph, line gets steeper. And to the equation, the first difference value goes up. Now if we decrease it to the table, the y values go up slower because you're adding a smaller amount each time. To the graph, line gets less steep. And to the equation, first difference value goes down. All right. If we change the fixed value or the initial value, all right, what happens to the table? The starting point goes up. All right, so the initial or the first value you use, goes up. Okay, we'll go higher to the graph. The line will start higher. And to the equation, fixed value is higher. Okay, what about the table if it decreases it? Starting value goes down. Goes down. To the graph, line will start lower. And for the equation, fixed value is smaller. All right. When you go through and do the homework and do the exit card or the journal, you'll get practice with all of these. But hopefully that makes sense. If you have any questions, ask your teacher for clarification. And we'll see you in the final spiral. Good luck on this test.